as shown in the process flow diagram. But if I say that we want to make some modifications in our design to make our process more energy efficient, you can see here that after separator V101 we have heater E101. The E101 is heating the stream V2 to the temperature of 10 degrees centigrade from its initial temperature, that is minus 20 degrees centigrade. Now see the cooler E100. The material stream V1 is entering at a temperature of 15 degrees centigrade, and the stream leaving the cooler has the temperature of minus 20 degrees centigrade. So the idea here is to remove the E101 and feed the stream V2 in the heat exchanger to the shell side, and feed the stream V1 on the tube side. So we are going to start from deleting some streams. Now add the heat exchanger from the pellet. Double click on it, and so the tube side inlet would be V1 and the tube side outlet will be V1 out. Okay, and the shell side inlet will be V2. This stream here, and the shell side outlet will be V2 out. Okay, so this is our final product, stream V2, and we are going to be saying unknown delta P. We will take care of it later, but first join the stream V1 with the cooler. V1 out. Okay, now give it some pressure drop, that is 5 kilopascal on the shell side and 35 kilopascal on the tube side. So select the parameters and we will use the simple weighted, and on the shell side we have a pressure drop of 5 kilopascal, and on the tube side we have a pressure drop of 35 kilopascal, as we did in our previous question. Okay, now go to the worksheet and the V2 out temperature is 10 degrees centigrade. Enter, and he's saying okay, we are okay to move forward. We delete this, and so we modified our process by doing a using a heat exchanger, and we have selected the simple weighted here heat exchanger model, that is simple weighted because the weighted model is an excellent model to apply to non-linear heat curve problems such as the phase change of pure components in one or both heat exchanger sites. With the weighted model, the heating curves are broken into intervals and an energy balance is performed along each interval. A logarithmic mean temperature difference and a heat transfer coefficient are calculated for each interval in the heat curve and summed to calculate the overall exchanger heat transfer coefficient. So with this simple design we have by using a heat exchanger we have modified our system, and now you can see that the duty uh, we want to give the stream to the temperature of minus 20 degrees centigrade, and the V1 out stream has a temperature of minus 6.453 degrees centigrade, and the only duty we are using here is one heat flow is on 1.88 into 10 raised to power 6 kilojoules per hour, and the duty here you can see that it is 1.88 into 10 raised to power 6 kilojoules per hour, and in this way we modified our system by simply using an heat exchanger. Thank you very much. This is from my side, and I hope you enjoyed it.